walk or just sitting outside, have you ever taken a closer look at some random lopsided flower only to find it having an oddly organized pattern in its center? Well, that isn't odd, first of all. In fact, you could go anywhere you wanted and you would still notice a lot of things around you give off that same sense of organization. The reason for that is because all these patterns are based off the same sequence of numbers. This is called the Fibonacci sequence, and it's at the very core for many things in nature where numbers appear.
Now, before we get into why this sequence is called Fibonacci, let's take a moment to understand what the Fibonacci sequence is. To put it simply, it is a pattern of numbers that perfectly repeats itself indefinitely. Even if you've never heard of this pattern before, it's still pretty amazing to think that one simple sequence of numbers can last forever, and that a sequence that incomprehensible exists in something as unassuming as that pinecone you kicked into the street because you wanted to see someone run over it. Probably the most famous example of this is the Fibonacci spiral. This is a shape that has been seen repeated in nature in a number of ways. From sunflower seeds to hurricanes to even galaxies, this spiral can be found anywhere. A Fibonacci spiral is made up of quarter circles that swirls outward indefinitely. If you start at 0 and 1, the sequence would go 0, 1, 1, 2, 3, 5, 8, 13, 21, and then 34, and so forth. The expression for this can be seen here. The numbers that make up the sequence are fairly easy to understand though. In a nutshell, the large number will always be the sum of the two smaller numbers before it. Easy to remember, right? As for why this is called the Fibonacci sequence, that's an entire history lesson in and of itself. Fibonacci is actually the pen name to Leonardo Pisano, a famous Italian mathematician that was around during the 1100s. Fibonacci was the son of a merchant, spending his youth traveling and trading. As one would imagine, math is a crucial skill for any merchant, so it's clear to see where his passion for numbers first originated. Fibonacci numbers were first introduced in his book called Liber Abaci, published in 1202. As for his discovery of the sequence, Fibonacci was trying to solve a mathematical problem involving rabbit breeding. Fibonacci's question was how many rabbits could be produced in 1 year, starting with a pair of them. After taking into account the amount of time it takes for a baby rabbit to mature and the amount of time it takes to reproduce, he concluded that 233 pairs of rabbits could be reproduced in 1 year. Aside from the historical aspect of Fibonacci numbers, the next thing we need to discuss is something called the golden ratio.
So, the golden ratio. What exactly is it? That's it. Thanks for watching. No, but really the golden ratio is much more than that, so let's break it down. Most people will have seen the picture of the golden ratio, but this is only the visual aspect. The golden ratio is actually a special number. This number is found by dividing a line into two parts so that the longer part, when divided by the smaller part, is equal to the whole length divided by the longer part. When put into the equation, it goes like this. Like pi, the digits for this number, theoretically, continue into infinity. This ratio is really important to the Greeks who discovered it. It was so important they even gave it the name phi. So how did this ratio become so important? The same thing as anything else. Aesthetics. For a long time, the Greeks wondered what made some rectangles more beautiful than others. Strangely enough, people do tend to perceive one particular shape as being more pleasing. This phenomenon led them to create the golden rectangle found around the well-known spiral. By measuring the side length of these rectangles and dividing the longest side by the shortest, you'll find the ratio somewhere around 1.6, or phi. Not only that, if you begin splitting the rectangle into a square and another golden rectangle, you can keep splitting them even further. So, what does this have to do with the Fibonacci numbers? Not much, actually. If you were to begin dividing each number in the sequence by the previous number, you'll find the resulting numbers continue to get close to 1.618, or phi, but really that's about it. The golden ratio is considered to be calculated beauty, but where can we find it? You can start by looking in the mirror. The mouth and nose on one's face are positioned at golden sections between the eyes and bottom of the chin. Look way closer and you'll find even DNA molecules contain a ratio approximate to phi. Take a step outside and you'll find it in nature. Flowers, shells, bees, and much more all adhere to the golden ratio. Look even farther and you'll find the world's most popular monuments, such as the Parthenon and the Great Pyramid of Giza, are made up of multiple golden rectangles. Keep zooming out and you'll find that our own galaxy contains the coveted ratio. One of the greatest examples of the golden ratio in the real world is art. Painters and sculptors will usually use the ratio as a kind of starting ground, creating their pieces to fit the ratio. The work of many prominent artists contain the golden ratio too. Figures like Da Vinci, Michelangelo, Raphael, Botticelli, and Dali all had created work with the golden ratio being present. It's even in music. Maybe. Some people speculate that music created by Mozart is influenced by the golden ratio, although he had stated that it was never intent. It is interesting to see that this mathematical component can extend all the way to music. Whether intentional or not, this supposed standard of beauty is almost everywhere, even in our DNA, so we are literally made up of math.
It is that simple. It is not hard to understand at all. Who knew that a face had a golden ratio, or that a flower had an odd sequence in the middle? The Fibonacci sequence and the golden ratio can relate to many real-life situations, as that is what it is based on. You can see the Fibonacci sequence almost everywhere that you go, including in the trees through the way the trunks grow and the branch spirals out of the trunk, or when you are looking at maps of storms. Yeah, storms, like tornadoes and hurricanes. It might be pretty scary, but some might say it is beautiful to look at. The Fibonacci sequence can make you wonder about how many things in the world could it work on. Well, that's for you to go out and see. Now, the golden ratio is seen as a rare beauty, but it is just as easy to spot as the Fibonacci sequence. You can see the golden ratio in faces. In fact, George Clooney is a 91% match to the golden ratio, and Bradley Cooper comes next. I know, nobody's perfect, but according to the golden ratio, George Clooney is 8% away from being perfect. It makes you wonder what else could have the golden ratio. Well, let me name a few things for you, starting with the Parthenon. This historical figure has not one, but multiple golden triangles between the columns. You can also find the golden ratio in other figures like the Chartres Cathedral in France, the Taj Mahal in India, and in the United Nations building located in New York. Now, the ratio is also found in famous pieces of art like Leonardo da Vinci's Mona Lisa, Raphael's Crucifixion, and Salvador Dali's The Sacrament of the Last Supper. The golden ratio truly shows off the beauty in the world. That is why it is also known as the divine ratio. Now, I hope that my two friends Connor and Victor really helped you understand what both the Fibonacci sequence and the golden ratio are. It is now up to you to go out in the world and try to spot as many different things that might have the golden ratio. And who knows, maybe you'll come up with a sequence or ratio of your own. Like Leonardo Pizziano said, if by chance I have omitted anything more or less proper or necessary, I beg forgiveness, since there is no one who is without fault and circumspect in all matters.